Number 44. The question on volume. The figure below represents a solid pipe of external diameter 42 centimeters. The thickness of the pipe is 14 centimeters and its height is 2 meters. What is the volume of the solid? So it's a pipe and it has an external diameter and an internal diameter, and I'll just draw that there. So the external diameter is 42 centimeters. We'll just analyze it first. And you're being told that the thickness, so let me just draw that one there. The thickness, you're being told that the thickness is 14 centimeters, which means from here to here, that's 14, and this side is 14 centimeters. So to get the internal diameter, we will take now the external diameter minus 14, which is 42, minus 28, and that's 3, that's 4, and that's 1, which means the internal diameter is 14 centimeters. So straight away, volume, no, this is 2 meters. So volume is equal to cross-sectional area multiplied by the height. So the cross-sectional area of this figure here is the area of this circle. Then we subtract the area of the inner circle. So we have pi r bigger R squared minus pi r smaller r squared multiplied by the height. So our pi, as we have been given, is 22 out of 7 times the bigger r. So our diameter, external diameter, is 42, which means our radius is 21. So times 21 centimeters times 21 centimeters minus 22 over 7 times our r. Inner diameter is 14 centimeters. And our radius is half the diameter, which means our radius is 7 centimeters times 7 centimeters, and that one you multiply by the height, and the height there is 2 meters. So since we are working with centimeters, so we change this 2 meters into centimeters, and that's going to be 200 centimeters. 200 centimeters over there. So 7 there 1, 7 there 3. So we have 22 times 3 centimeters times 21 centimeters minus 7 there 1, 7 there 1. So we have 22 times 1 centimeter times 7 centimeter multiplied by 200 centimeters. So 22 times 3 centimeters times 21 centimeters is going to give us 1,386 square centimeters minus 22 times 7 centimeters times 1 centimeter, that's 154 square centimeters. That one you multiply by the height, which is 200 centimeters. So let's subtract this minus this. So that's 1,386 minus 154. 6 minus 4, that's 2. That's 3. That's 2, and that's 1. Means here we have 1,232 square centimeters multiplied 200 centimeters. So you multiply this one here by 2. 2 times 2, 4, 6, 4, 2. So we have 2, 4, 6, 4. Then 1, 2 zeros. 1, 2, and volume, that's in cubic centimeters. So the answer here is 246,400 cubic centimeters. And when you come to the choices, 246,400 is there in choice B, if you can see it. So what I've just done, I've just gotten the volume, excuse me, I've just gotten the volume by getting area of this bigger circle minus area of the smaller circle, and I've multiplied by the height, and that has given me 246,400 cubic centimeters in choice B. Number 43. The figure below shows a block of wood from which a semicircular groove of diameter 14 centimeters has been removed. What is the volume of the remaining part? So we have this, the block of wood, the low it, and then now this semicircular groove, this one part, this part over here has been cut out. So solving it, so the formula of getting volume of a solid is cross-sectional area multiplied by the height. So let me push it here. So your volume is cross-sectional area multiplied by the height. So if you look at this figure here, the cross-sectional area of this figure is this one, this part over here. And this part we have it's a rectangular shape in which a semicircular shape has been removed. So which means we're going to get the area of a rectangle minus the area of half a circle, and then that one you're going to multiply it by the height. So area of a rectangle is length times width, and then minus area of this half a circle over here is a half pi r squared, and then that one we are going to multiply it by the bigger height. So area of the rectangle, the length is 14 centimeters multiplied by the width, this one over here, and this one is same as this, which is 10 centimeters, and then that one minus a half times pi is 22/7 times radius. So the radius of this figure here, so from the radius is from the center, so from here to here is 14, which is same as this side, which means the half of the diameter is 7. So the radius is 7 squared, and 7 squared is 49, and that one multiplied by the height, and the height is this one here, which is 15 centimeters. So let's say, so 140, 14 times 10, that's 140 square centimeters, which means this 140, that's the area of now this rectangular part, and then minus a half times 22/7 times 49, 2 there ones, 2 there 11, 7 there 1, 7 there 7, so 11 times 7, that gives you 77 square centimeters, brackets, and then we multiply by 15 centimeters. So we have 140 minus 77, this one will give you 63 square centimeters multiplied by 15 centimeters. So we have subtracted this part here because the semicircular part has been cut. That's why we get the area of the rectangle minus the area of the half a circle. So now 63 times 15, which is the height, that will give you 945 cubic centimeters, and that's the volume. So if I go through what I've done again. So we want the volume of the remaining block of wood, since you're being told that it was a block of wood, it was a rectangular block of wood, and a semicircular groove was cut, which means a cylinder was cut from it. So what I've just done, I've written the volume of the formula of getting the volume. This is basically the general formula of getting the volume of solids, which is the cross-sectional area multiplied by the height. And the cross-sectional area of this solid here, as I've said, is this part over here, and this part we have the rectangle just been in which a semicircle has been cut. So that's what we've written here. So area of a rectangle, which is length times width, minus area of half a circle, which is a half pi r squared multiplied by the height. So I've gotten the area of the rectangle, area of this rectangle, minus area of this semicircle. So this is the rectangle minus the semicircle, and then I've subtracted since it was cut out, and then I've multiplied by the height, and I've gotten 945 as my answer. So when you come to the question here, we have 945 in choice C. So that the answer there is choice C. Another question on volume. A cylindrical hole is drilled through a rectangular block of wood. What is the volume of the remaining block of wood? So this is the block of wood, and then a hole is drilled. So as we have done in the previous questions, we'll just go straight away to this number 47. Volume is cross-sectional area multiplied by the height. And as we said, since a cylindrical hole has been drilled, so the cross-sectional area, we're going to take the area of the square minus area of the circle, since the circle is the part which has been removed. So I will write there the area of a square, that side squared, minus area of a circle is pi r squared, and then that one multiplied by the height. So let's bring that close there. So area of a square, that side is 300 times 300, so it means we have 30 times 30, thus we have 30 centimeters squared minus 22 over 7 times radius, there is 7 centimeters times 7 centimeters. Then that one we multiply it by the height, and our height there, our height there is 40 centimeters. So we have times 40 centimeters. So 30 squared, that's 30 times 30, and that's 900 square centimeters. Then minus 7 there, 1, 7 there, 1. So you have 22 times 7 centimeters times 1 centimeter, and that's going to give us 154 square centimeters. And then that one we multiply it by 40 centimeters. 900 minus 154, that's going to give us 746 square centimeters. We multiply it by the height, which is 40 centimeters. And when you multiply 746 times 4, you are going to get 29,840 cubic centimeters. So that's our volume And when you come to the choices here, 29,840 is in choice D. So our answer there is in choice D. So these are some of the Kcpe questions on volumes which you are likely to find in your Kcpe exam, which is oncoming. So check them out, and if you like the video, like it, and you can subscribe to the channel.